Thank you for stopping by my poster. I'm Glen Wurden from Los Alamos, and I work on W7X in Greifswald, Germany. In our last campaign, we had a remarkable discharge, at least I find it that way. Basically, it was going to be a 2-gyrotron shot. Here you can see the ECH heating power going along, and about 15 seconds into the shot, one of the 2 gyrotrons quit working. So the remaining 40 seconds of the discharge ran on 1 gyrotron. Now, the remarkable thing is that I noticed right away, here's the stored energy, a little over 200 kilojoules. It, of course, drops when you cut the heating power in half, but it climbed all by itself to a value higher than it was with 2 gyrotrons, but only running with 1. And it took about 2 seconds for that to happen. You notice up here, the black trace is the central Thomson scattering value. The density profile peaked up. We weren't doing anything actively from the outside. In fact, the gas puffing actually turned off because the set point was lower than the actual density that was occurring. We don't need CNN. The CO2 line average density increased slightly as well. The Z effective went from about 1.6, climbed to about 1.9, but then stayed that way for the rest of the discharge. Of course, the central electron temperature dropped. The blue trace is the X-ray crystal spectrometer central ion temperature, which when we have flat profiles heated by ECH is usually always lower than the electron temperature. But you'll notice what happened is it actually climbed to about 1.8 kilovolts, nearly equaling the electron temperature during this time. Now, the other thing that happened is that the fluctuations changed dramatically as the density profile peaked. And so before, this is taken from 13 to 15 some seconds, you can see kind of a quasi-coherent H-alpha, carbon light, soft X-ray radiation on 4 chords that are actually down in this corner looking through one of the 4 edge islands in this high iota configuration. So there's a very small occasional sawtoothing activity, but I call this the quasi-coherent continuous oscillation. Well, after the transition, and this is from 20 to 20 and a half, this is actually 400 milliseconds worth of time, is you can see regular periodic sawtoothing. I call these island localized modes. We actually can tell by the X-ray array that they're out here in the very close proximity to the edge islands. Whether they're inside the island just a little bit or not, we don't have sufficient resolution yet. But what you can see here is an inversion. This outermost chord, which is down at this corner through the X point, shows a pulse of X-rays coming up. You go to the next chord, you see kind of both phases, and then a little bit further in, and you just see it dropping. And then right across the middle of the island, you basically don't see anything happening. So this is what one can refer to as an ILM, island localized mode, or more conventionally, you might call it an ELM, an edge localized mode. Yeah, so the fluctuations decreased during this time. The orange is the after the transition, the blue is before, as a function of frequency seen by the PCR reflectometer. The profiles peaked up, orange is after, blue is before. This is density. Over here you see electron temperature. Of course, it reduced because the heating to the electrons was cut. And the ion temperature, though, actually peaked up. This is a measure of the radioelectric field, which moved inward. The blue and orange lines are actually from a model, suggesting that there's slightly more negative electric field after the transition. There was an increase in the iron 22 radiation. The core bolometry showed this, showed the increase in overall radiation. The hexos spectrometer showed specifically that it was iron. Now, what I want to do is show you a little bit more. Let me stop this share and let me share again another trace here. So this is now just in detail showing a partial Rogowski. That's a large current perturbation. The stored energy, small sawtooth crashes, these are in the edge, these are not in the core. H alpha bumping along, near enough bumping along, and line density slowly increasing. Here actually is a larger view showing fluctuations before the transition and then after the transition, a very noticeable difference. You can see these ILMs in multiple diagnostics, whether it's the continuous total current, toroidal current, or a partial Rogowski, very clear signatures of crashing events, an unstable event that continues periodically. So what's also interesting here is boron 4 before and after the transition, carbon 2, these were looking in one of the diverters, oxygen 3, and just to show you that the light impurities actually, intensity actually decreased, even though the density was increasing. So the increase in radiation is actually from the higher Z charge states. And again, here's just profiles before the transition. And you see the blue here, that's the ion temperature, well separated from the electrons. Then after the transition, it's now in close proximity to the electron temperature. So I hope you can take a look at the poster itself. There's also a paper available, and feel free to contact me if you want to chat further. Thanks a lot. Bye.